Hi everyone, I'm Jessica, a first-year PhD student in the Material Science Department at Imperial College London. Today I'll be talking to you about my research, which is using 3D printing of titanium for bone and joint replacements. Our bones are extremely strong. When compared with concrete of the same weight, bone is up to 4 times as strong. To give an illustration, a cubic inch of bone can carry a load equivalent to 6 small cars. This is because our bones are extremely light, thanks to their hollow structures. Despite their incredible strength, bones still fail sometimes. You might have broken a bone before. Younger people's bones are still growing and therefore not yet as strong. On the other hand, older people tend to have more brittle bones and weaker joints, where 2 or more bones meet. As we age, our bones and joints show wear and tear from decades of supporting our body weight. There are many artificial materials that can replace bone, and these have been used in knee and hip implants for decades. Titanium alloys is one of them. Firstly, it is a light and strong material, just like our bones. For comparison, titanium is as strong as steel, but 46% lighter. It is also twice as strong as aluminum, but only 60% heavier. Furthermore, titanium is non-magnetic, which allows someone with a titanium implant to pass metal detectors in airports, for example. Titanium also does not release toxic products to our bodies and is considered very safe. Lastly, but perhaps most importantly, it can withstand continuous movement without wear and tear, thanks to a naturally occurring oxide layer that protects the metal. Aside from material considerations, manufacturing implants can be difficult due to the complex geometry of our joints. Conventional technology uses screws to connect different parts together, but there is always a potential that these screws can loosen while in the body, requiring further surgery to correct. Enter 3D printing. 3D printing is a new exciting technology that allows us to make complex shapes. Recent advances in material science have allowed 3D printing of not only polymers, but also metals and ceramics. In particular, we can replicate the hollow structures of our bones quite easily using 3D printing. These hollow structures are called lattices. By making implants hollow, we effectively mimic the structure of our bones. Our bones also continuously grow, so they will grow into the hollow part of the implant, ensuring it doesn't become loose or dislodged in the future. Now, there are several pros and cons of using 3D printed metal lattices for our implants. The main benefit is, of course, we can make everything as one component, so we don't need to worry about adding screws and fasteners. This is good because we do not want to worry about screws becoming loose or infecting our cells. As I said before, it also mimics the structure of our bones, so our bones can grow into them and function together. Because of this, it will last longer, and we don't need to worry about more surgeries to replace them 10 or 20 years afterwards. However, as the structure is quite complex, it can be difficult to make, and the design has to be very carefully considered. 3D printing machines for metals are also expensive because temperatures of 1000 degrees Celsius are needed to melt metals. Lastly, since this is a new technology, we're still unsure of the long-term effects in the body. One of the potential issues is corrosion because of the hollow structure that will be filled with our body fluid. This is actually the topic of my research. Having a compatible implant material and structure is important as it is easier for the implant to integrate well with our body. All in all, I think 3D printing of titanium for body implants is a new and promising technology for the future. Thank you for listening. Have a great day.